Assalamualaikum and a very good morning to all. Okay, from the participant list, I can see there are around 18 students. How many students altogether? Yeah, I suppose probably around 30, is it? Does anyone know how many students in this lecture? Can you hear me? Anyone can hear me?
Yes, Doctor.
Yes, we can hear you.
So normally, how many students here in this class?
Probably 25, Doctor.
Okay, around 25. So I think we can start now. All right. I've start recording. Okay. So welcome to the second half of the semester. Yeah. So I'll be taking 7 topics. Yeah, around 7 topics after the mid-semester break. So let me introduce myself. Probably you have seen me before. My name is Prof. Nur Ezlin Ahmad Basri. I think most probably that I have taught you in your second year, yeah, in your second year on the course of Introduction to Environmental Engineering for Civil Engineers. I hope so. Okay, first of all, before we start this lecture, I just would like to know you better. Probably, I would like to ask you to open up your video, and just tell me your name, and then where you are from. I think where you are from. Just the two of it only. That will be enough. Okay. Who would like to start first? Probably I just call. Yeah, any one of you. So I will start with the top student. Yeah. Afrina Anwar. Can you introduce yourself?
Hello.
Okay.
My name is Afrina Yusra.
Can you open up your video? I just want to know you because when
I'm not wearing tudung.
Oh, you're not wearing tudung. Okay, so I just imagine. Okay.
I'm not prepared.
Oh, you're not prepared. Okay, it's okay. Just tell me more about yourself.
So currently I'm at home in Semenyih.
Okay, you're at home. Semenyih, very close.
Yes.
You can.
And apa tadi doktor Prof nak tahu lagi?
Tu sajalah. Tapi I actually nak tengok how you look like so that I can imagine when I'm teaching you how my students look like. Yeah. Previously, we are allowed to see the students. Now I cannot see the students, so I need to imagine how the students look like, so that I can absorb your feelings. Yeah, I understand what's your problem. Just like, okay, Afrina, thank you very much. If you have any other things to tell me, is there any more that you want to tell me?
No.
No. Okay, thanks, Afrina.
Thank you.
Okay, the second one, Ahmad Luqmanul Hakim. Luqman Hakim. Yes. So I think I've seen you before. I think in your industrial training, is it?
Yes.
Yeah. Can I see your face?
Right now? Can.
Can. Oh, bukan yang tadi ya. Okay.
It's me.
Pasti we have discussed for your presentation, right?
Yeah.
Industrial training.
Last time.
Okay, where are you now?
I'm at UKM.
Which college?
Ungku Omar.
Omar. Everything is fine there in the college?
Alhamdulillah, everything is good. Everything is fine.
Okay, thank you, Lukman. Okay, Akasha, the next one, Akasha. Akasha Radi. Ada, Akasha? Tak ada. Okay, Akasha, I will get back to you after this. Dirham? Dirham ni, I think so familiar. The name is so familiar. I think I remember you during your first year Etika class, I think. Okay, I cannot hear your voice. I think you are being muted.
Sorry, Doctor.
Okay, your full name?
My name is Muhammad Dirham bin Bidi.
Where are you now?
I'm in Dungun, Terengganu.
Oh, very far away. But I think the internet has no problem, yeah? Okay je, nampak? Anything that you want to tell us? Tell me. That's all. So you are not coming back for this semester?
Next week.
Oh, okay. Tadi siapa ya tadi yang duduk kat semuanya? Afrina. Okay, thank you, Dirham. Thank you.
Doctor.
Yes.
Afrina, are you coming back to UKM?
Yeah, most probably this Monday.
Okay. Okay, Afrina, Dirham dah. Fariza Hafiza.
Ya, Doktor.
Fariza.
Ya, Doktor.
Your video?
Video?
Your face. I want to see your face. Duduk lah. Duduk.
Prepared, Doctor.
Duduk cincai pun tak apalah. Like that also can.
Jangan, Doktor.
Okay. Lepas ni, I will call you after this. Fatin Azira. Unless you are ready. Farisa, are you ready? Not yet. Okay, Fatin dulu
Wait,
lah.
Doctor, wait, I'm not prepared.
Oh, you also not prepared. You get prepared. Just put towel lah. Towel.
I grab some towel.
Towel pun okay lah. Irdina Syukri. Ni siapa? Irdina. Okay, Irdina.
Yes.
Where are you now?
Can you hear me?
Yes, I can hear you very well.
Now I'm at College Pendeta Zakbar.
Pendeta Zakbar. Okay. So when did you come back to UKM?
I stay here from the intern.
Oh, meaning that immediately after completing your internship, you already back to UKM?
No.
No.
During internship, I just stayed here.
Oh, okay. Oh, your internship was with Prasarana?
Yes.
Okay. Oh, you made a presentation last time, right? For the okay. Okay, thank you, Irdina. Tadi yang Farisa dah ready. Are you ready, Farisa? Have you put the towel?
Belum.
Fatin
Belum, Doktor. Okay, dia dah ready, Doktor.
dah ready. Siapa yang ready dulu? Fatin ke Farisa?
Kita orang berdua.
Oh, duduk satu college ke?
Kita satu bilik.
Oh, padahal dua-dua pakai towel. Okay. Siapa dulu? Fatin dululah. Dia nampak tengah cakap tu kan? Mana Fatin ni dah hilang pula. Farisa? Pun tak ada. Oh, lost connection. Oh. Cantik towel tu. Towel ke? Cantik lah tudungnya. Ni kat bilik ke?
Ya, Doktor kat bilik.
Share kan? Seorang, satu bilik, dua orang? Okay, yang mana satu Fatin?
Yang saya Fatin, ni Farisa.
Ah, okay. So, actually, rumah asal dari mana, Fatin?
Saya duduk dekat cyber.
Oh, dekat je lah. Saya berjaya? Dekat. Okay, Farisa?
Saya Melaka.
Melaka. Dah lama sampai sini?
Dah dari week 5.
Oh, baru jugalah. Kan, ni baru week 8 kan? Okay. Thank you. Terima kasih Farisa and Fatin.
Okay, Doktor.
Okay. Next, Jason. Jason Lee. Are you here, Jason? Hi, Jason.
Hi, Doctor. Good morning.
Good morning. Your full name is?
Doctor, my full name is Jason Lee Wei Sin. I'm from Alostar, Kedah.
Oh, so you're still in Alostar? No?
Yes.
Oh, okay. Are you planning to come back sometime? Soon?
Maybe next year.
Next week?
Next year.
Oh, next year, the next semester.
Yes.
Okay. Thanks, Jason.
Okay.
Okay, next, Kang Ziying. Ziying.
Yes, Doctor.
Hi, Ziying. So, how are you today?
Fine.
Where are you now? I can see only blur. Your background is blur.
Background very messy.
It's okay, no problem.
My
Okay.
name is Kang Sing. I'm in.
Are you
I am at home. Yeah. At home.
Where is your home?
Yongpeng, Johor. Johor.
And when you to come back? When do you plan to come back?
Maybe next semester.
Next semester. All right. Okay. Anything else you want to tell me? How's the weather in Yongpeng?
Quite nice.
Sunny. Yeah, it looks sunny from the. I can see some sunlight from your window. Okay. Tadi siapa? Ziying. Okay, thank you, Ziying. Next is Lee Sengyip. Sengyip.
Hi, good morning. Can you hear me?
Good morning. I can hear you.
My name is Lee Sengyip. I come from Kelantan.
Oh, Kelantan.
And now stay at Dengkil.
Stay where?
Dengkil.
Dengkil. Oh, your relative house.
Rental house.
Oh, rental house.
Yeah.
Okay, so you're not coming into UKM yet, into the campus?
Very near, around 5 minutes. Yeah.
So you can come back anytime. Your thesis, what's the topic of your FYP project?
Recycle concrete, about something like that.
With Dr. Izzy.
Dr. Ahmed.
Dr. who?
Ahmed Wadud.
Ahmed. Oh, okay. Okay, thank you, Sengyip. Next, Ashraf, Muhammad Ashraf. Ashraf. Oh, bukanlah dekat Dewan tu kan? Dewan ke? Dekat study depan Dewan pula. Okay, where are you? At home. Oh, UKM. Di mana di UKM tu? College mana? Okay, duduk satu bilik seorang ke? Okay, so tadi apa nama? Ashraf Ashraf. Okay, terima kasih Ashraf. Next, Muhammad Afiq Nur Izani. Betul? Muhammad Afiq.
Betul.
Okay, Afiq. Muhammad Afiq. So, di manakah anda?
Saya dekat UKM sekarang, betul.
College? Pengurusan. Bila balik sini?
Awal semester hari tu.
Awal lagi lah. Kampungnya di mana? Kampung, rumah, home.
Rumah saya Serempan.
Okay, dekat je lah. Okay, Afiq dah. Nik Muhammad Zaki. Okay, Nik Muhammad Zaki. Satu bilik dengan tadi ke? Afiq tadi ke? Macam sama je background. Itu saya rasa bukan bilik tu kan. Tu filter ya. You're ni muted. You're being muted.
Okay, dengar tak tu?
Okay, dengar. Asal dari mana?
Saya Nik Muhammad Zaki. Sekarang dekat Kuoma.
Okay, kampung, rumah, home?
Dekat Kelantan.
Kelantan. Okay, sebab tahulah nama Nick ni mesti dari Kelantan ni. Kelantan di mana?
Kuala Kerai.
Kuala Kerai. Bila balik ke UKM?
Walsam itu.
Okay, Nick, terima kasih. Next, Nur Adura Azni. Tak pakai tudung lagi? Oh, dah pakai tudung. Baik.
Assalamualaikum, Doktor.
Waalaikumsalam. Dekat mana ni?
Kenapa ni?
Dekat mana? Oh, tak dengar?
Saya dekat Pendeta Sabah.
Oh, College Pendeta
Dekat
Sabah.
Sabah.
Guna apa? Wi-Fi ke? Macam tak kuat je. Wi-Fi?
Wi-Fi UKM sini sikit.
Oh, ya ke? Dia orang kata dah upgrade hari tu. Kadang-kadang okey, kadang tak okey.
Doktor, tapi ada macam tu.
Okey, tapi boleh dengar lah saya cakap ni. Boleh dengar.
Boleh, tapi dia macam lag-lag sikit.
Okey. Asal dari mana? Rumah?
Saya dari Setiawan Perak.
Setiawan? Di mana? Tak dengar.
Ya, betul.
Okey. Bila dah sampai ke UKM?
Awal semester.
Okey, semua okey lah di kolej mana ke tadi? Kolej apa?
Alhamdulillah, okey.
Kolej apa? Kolej?
Kolej Pendeta Sabah.
Oh, dekat fakulti lah. Okey, terima kasih. Saya cakap mana tadi? Nur Adura kan? Nur Adura ya?
Ya.
Okey, Adura dah. Okey, next Nur Izzati Akilah. Nur Izzati.
Ada. Saya punya kamera tak boleh buka.
You punya apa? Tak apa dengar pun.
Kamera tak boleh buka.
Oh, tak boleh buka. Okey. Okeylah. Sekarang ni berada di mana?
Dekat rumah, JB.
Di mana?
Dekat rumah, JB.
JB. Okey. Bila nak datang UKM?
Next semester.
Okey, Izzati. Terima kasih. Seterusnya Nur Syahima. Okey. Nur Syahima. Ada tak?
Ada.
Ada. Mana dia? Dekat gym lah sekarang ni. Bukan kat gym. Kat mana tu?
Saya dekat UKM.
Dekat UKM. Okey. Di mana college?
Sabah.
Bila sampai ke UKM?
Minggu 5 hari tu.
Minggu 5. Baru lagi lah. Asal dari?
Dari Kuala Selangor.
Kuala Selangor. Okey, terima kasih. Seterusnya Nur Syamimi. Nur Syamimi.
Ya, saya Doktor.
Syamimi. Okey. Tingkat berapa ni? Di mana sekarang? Macam tinggi je bangunan? Macam tinggi je bangunan?
Saya kat rumah je Doktor.
Oh, kat rumah. Di mana tu?
Dekat Bangi.
Oh, dekat rumah saya lah. Bangi. Section berapa?
Saya section 8.
Ada datang ke UKM? Belum lagi lah. Tak masuk UKM lagi, kampus.
Ada masuk sebab saya pun macam baru start lepas mid-sem ni kena ambil masuk lab untuk JIS.
Projek apa tu? FYP ya? Oh, kelas tu.
Kelas JIS
tu. Okey. Okey, Syamimi dan I think yang terakhir lah Rachel Kaur. Rachel?
Yes, Doctor.
Hi.
Yeah. I'm Rachel from Ipoh, Perak.
Oh, Ipoh Perak. Oh, that's my hometown, Ipoh Perak.
Oh.
Okay, so when are you planning to come back to UKM?
Maybe next semester.
Next semester. So your FYP, what are you going to do?
The development of black soldier fly industry in Malaysia.
Development of what industry?
Black soldier fly.
Oh, under Dr. Irfana.
Yeah.
Right. Okay, I think there's one topic today that we are going to learn about black soldier fly. Okay, so I think we should start our class now. Thank you very much, Rachel. All right. Okay, so I think I will share the lecture notes for today. Okay. Okay, can you see the lecture notes?
Yes.
Yes.
All right. Okay. So now we are in week number 8. So the topic continues from last week. I think you still have class last week, isn't it? With Dr. Irfana.
Yes.
Okay. So the topic for today is about biological and biochemical waste treatment. Actually, we are looking into few technologies or treatment options for treating mostly, because when we are talking about biological and biochemical treatment, we are talking the organic component of the waste, yeah. Because I think you already have learned earlier with Dr. Irfana that solid waste, yeah, municipal solid waste. Municipal solid waste means waste coming from household, yeah, meaning from our home, waste coming from commercial areas, yeah, coming from institutional areas such as universities, schools. So from the study on waste composition, you found out that most of the waste generated in municipal solid waste consists of organic waste. Yeah, almost 50% of the waste actually consists of organic waste. And for organic waste, the most appropriate treatment is biological or biochemical treatment. Okay, so actually today we are going to learn about aerobic composting, anaerobic digestion process. We also I'm just going to touch a little bit on BSFL, black soldier fly larvae. Yeah, black soldier fly meaning that we are using insect to treat waste. And the last one is vermicomposting, meaning that we are using worms to treat waste. Okay, so actually I will write, there should be another 2, yeah, from these slides. Okay, so when we are talking about waste management, yeah, solid waste management, we are also referring to integrated solid waste management, meaning that we are looking from waste generation, where the waste generated from our homes, yeah, from the commercial areas and so on. After it's being collected, and then probably it is being stored either from at our home, or it is stored at the facility, yeah, certain facility, before it is being transported for treatment, recycle, or before it is being disposed to landfill. Okay, so when we look at the functional elements, we are looking into the part of processing the waste and transformation, meaning that we want to process the waste and produce new products from the waste. Yeah, that is actually the main target. Yeah, if you remember about the Sustainable Development Goal (SDG), now it is being considered as very important for general waste management of general environmental management. Yeah, we need to consider the waste that we produce and transform or process it into new products, because we do not want to send it to landfill. So we have to think about what are the ways, what are the methods that we can use, that we can consider, our technology that we can use in order to produce new products. Yeah, we do not want to send the waste to landfill anymore. Yeah, we want to divert the waste from being disposed to landfill. So processing of organic waste is a method of trying to ensure that our waste that we produce daily will not being disposed at landfills. Okay, so issues, even landfills here in Malaysia, and not only in Malaysia, yeah, actually it is a worldwide issue. Yeah, but it is in Malaysia, it is one of the pressing problem that is being faced by the government in order to identify new locations for waste disposals. Yeah, and now since the waste generation is so much, the waste will need to be transported in a very long journey. Yeah, most probably 80 kilometers or more in order to dispose the waste, because there's no more land available nearby the city, nearby the town. Yeah, so it has to be transported to a very far distance in order to be disposed at landfills, and it is not economically feasible anymore because transportation will require quite a lot of cost. Yeah, for transporting waste. So from the issue that I've mentioned earlier, almost 50% of our waste generated is actually organic waste. Yeah, this is here mentioned that almost 47% is organic waste that consists of food waste and also landscape waste or garden waste. Okay, so now we look at the first option, the first treatment option, using composting method. Yeah, so composting is actually, it's a biological treatment. Yeah, and what is the difference between aerobic composting and anaerobic digestion? Yeah, the main difference is that the microbes that present in the waste are actually aerobic microbes, yeah, or aerobic microorganisms that are active during when there are oxygen present in the pile, yeah, or in the waste. So when there are oxygen present in the waste, so aerobic microbes or microorganisms will be active, and there would be a process, yeah, a biological process activated by aerobic microorganisms, and the product will be a compost product. Yeah, what we call it as organic fertilizer. Organic fertilizer, which is named as compost product. Yeah. Okay. Next. So actually for composting, the most suitable type of waste that can be composted are garden waste, branches. Yeah. So mostly it comes from the landscape. Yeah, or wood chips. Would be fruits, vegetables, eggshells, tea, dirty tissue papers, and some food waste. Actually, what we can say is that organic waste all can be composted, but in order to prevent problematic issues during the composting process itself, we select the materials or the waste that will not cause problems, because if you put together meat, fish, and other waste, other food waste, it will actually create a problematic situation where probably some animals such as dogs, pigs, or even rats, cockroaches, it will attract those animals, or insects, or even rats. So, and normally composting is in an open space, so we are trying to reduce problems. So we are most people are considering non-problematic waste such as fruit, garden waste, vegetables, in order to ensure there's no problems during the composting process. Okay, so what are the mechanisms for composting process? Okay, normally when we say composting, so we are putting together food waste, organic waste, landscape waste, in a pile, in one macam satu pile, satu timbunan. Satu timbunan, we place it in a timbunan or a pile. And the input would be organic waste, our organic waste. We need to add some water. We need to add oxygen, microorganisms, microbes. Microbes actually, they are already present in the waste. They naturally, it is already present in the waste. And sometimes we will add enzyme. Enzyme which is such as microbes, special microbes, in order to enhance the process, to make it faster, and also to reduce smell. So these enzymes will help to activate the microbes in the waste, and making the process even faster. Okay, so that would be the input. And then during the process, we will have to make sure that there would be enough water or moisture in the pile. We have to make sure that oxygen should be there, enough oxygen for the microorganisms to do their activities, to eat the waste. Because if there's not enough aeration or oxygen in the pile, so the pile will be there won't be enough oxygen, and then it will change into anaerobic condition, because when there's not enough oxygen, it will become anaerobic without oxygen, and therefore it creates bad smell, and it becomes another process which is called anaerobic digestion. So we have to make sure that for composting, aerobic composting, we have to make sure there would be enough oxygen and moisture, or optimum oxygen and moisture for the microorganism to become active and eat up the food waste or the organic waste. Okay, so from this process, there would be some output, which means you can feel the heat. It will be warm. It will be quite warm, because the temperature may rise to 60 degrees Celsius, 40, 50, 60 degrees Celsius, in order to kill off the bad microorganisms or the bad pathogens. So during the process, we have to make sure that pathogens or bad microorganisms will be died off. So there would be heat coming naturally from the process. And then we are expecting there would be carbon dioxide also being released, water vapor, and also ammonium. Ammonium will be released. And finally, the product that we will get is a compost product or we call it as organic fertilizer. Okay, any question regarding this? Anything that you would like to know? Okay, so if there's no question, I will continue. Okay, so what are the process requirements for composting? Yeah. Okay, so carbon is important. Yeah, carbon, nitrogen, oxygen, and water. So it is actually why does carbon is important for the process? Okay, firstly, because carbon will provide energy for bacteria to produce heat to increase temperature. So it is like like food for the bacteria, yeah. Then which actually will convert the food into energy, yeah, and it will make the pile become more heating, yeah, more heat, and increase the temperature. And the color would be carbon, yeah, of course it will be like brownish color, and normally it would be dry, yeah. So when you look at the leaves, yeah, leaves or food waste that that is actually the color is like brownish color, so you would consider that the waste consists more on carbon waste, yeah, carbon, the waste that contain more carbon. Okay, next, for the process, it requires nitrogen. Okay, carbon, nitrogen. Why does the microorganism require nitrogens? Because it's for the growing and reproduction of more organisms to oxidize the carbon. Yeah, so in order to oxidize the carbon, and it also will help the growth of the bacteria, yeah, microbes, yeah. And then normally the color would be green and it is wet, yeah. So for example, vegetables, yeah, greenish vegetables will contain more nitrogen, yeah. Okay, then oxygen, of course, I mentioned just now, oxygen is for the microbes, the aerobic microorganisms to use up the oxygen and doing their process, their work, yeah, for the decomposition process. And water, yeah, it cannot be too much water, it cannot be too little water, it should be enough, yeah, it should be optimum water requirement, yeah, the right amount to maintain activity without causing anaerobic conditions, which is not too wet or not too dry. Okay, so what are the microorganisms present during the composting process? Okay, so during the composting process, in our waste, in our waste pile, there would contain a lot of microorganisms. So who are they? Yeah, what are the microorganisms present in our waste? So firstly, of course, because I've already mentioned that there would be aerobic bacteria, there would be anaerobic bacteria present. Of course, even though they are not active because of the temperature, yeah, because of the oxygen present, because anaerobic bacteria will only be active when there is no oxygen present. So it will be active and the process will be different, the product will be different, yeah. Okay, so still they are present in the waste. Fungi would be present, protozoa would be present, and rotifer. So in our waste pile, there would be so much of microorganism present, yeah. So for composting process, we are looking into the aerobic bacteria, where we want to activate their activities and we want to ensure their reproduction so that they will degrade the food waste, the organic waste into products, yeah. Okay, so we are expecting that these microorganisms will be active and at different phases, yeah. We call that the first phase is mesophilic phase, where the temperature is 35 to 45 degrees Celsius, and further it will go up into a higher temperature that we call it as thermophilic phase, where it is the temperature will rise as high as 70 degrees Celsius. So this is important because in order to kill off pathogens in the waste, the temperature should be high. Okay. Any questions until now?
No.
No. Okay, I'll continue. Okay, so if we are talking about composting, yeah, still there are so many technologies, so many methods being developed, yeah, because if we are talking about composting, it is not a new process. If you have read the history of composting activities, it goes as a long time ago, maybe 100 of years ago. But then it is like a normal, I mean, it is not being controlled. Presently, the technology is that we want to control the temperature, control the oxygen, so that the process will be faster, yeah? And we are adding microbes, enzymes, in order to make it fast, okay? So composting will be differentiate by open process, which is being open to air, yeah, or it's a mechanical process. This is some typing error. Mechanical process, such as rotating drum or bioreactor, yeah, and put it in bioreactor. So open process would be such as windrow, yeah? We call it as windrow composting. I will show you. Normally windrow composting is like we are piling the waste into a very long pile, and then we will actually turn the waste so that oxygen will be introduced into the pile, yeah. Okay, so there would be windrow composting. There would be a method that we call aerated static pile, where the pile is not being turned, yeah. The first one, yeah, the pile being turned, yeah, dibalik-balikkan so that oxygen can get in. But for the aerated static pile, as the name says, it is static, yeah, so it is not being turned, but instead we are introducing oxygen at the bottom of the pile by having what we call this piping system at the bottom of the pile, yeah. Okay, so that's another type, and I've already mentioned earlier, there would be vermicompost, yeah, vermicomposting, where we are using worms, yeah, worms to eat up our waste, food waste, or yeah, normally worms will like more food waste, yeah, and then it will turn into organic fertilizer as well, yeah. Okay, and the other one is the mechanical system, such as rotary drum. Okay, so this is the picture of a composting facility at UKM. This picture is actually during the initial stage of the composting facility, where actually they are making a small windrow, yeah, a small windrow. And this is actually the Prasarana UKM, yeah, Prasarana UKM. We tried, I mean, together, yeah, I mean, our researcher at the Faculty of Engineering and Prasarana UKM, Jabatan Prasarana UKM, we are actually, this is during the development of the compost facility, yeah, at UKM. Okay, so these are the picture of food waste. Mostly what you can see here is vegetable waste. But if you go to the cafeteria, probably you can see more of like this. There would be rice, leftovers, yeah, some fruits, yeah. But here in this bin, you can even see uneaten or food waste, yeah, meaning that probably it is, I mean, end of expiry date, so they just throw it away, thinking that it's no good anymore. So it goes to our bins, yeah. So many types of food waste that you can find in our bins. Okay, So aerobic composting is a natural process. It's old, yeah. It is well understood, socially attractive option because it is a simple technology, yeah. Okay, I've already mentioned this one. So theoretically, yeah, composting refers to the control biodegradation of organic matter by microorganisms into stable humus material. So here, the product is called stable humus material. So it looks like something, I think I have the picture. Oh, it's not here. Okay, it looks like soil actually, yeah, humus material looks like soil. So when we are talking about organic fertilizer, the look, yeah, the physical look actually is similar to our soil, yeah, tanah. It looks like soil. Okay. Okay, composting actually can reduce the volume of waste. So if we are having problem with the amount of waste that need to be disposed, actually composting is one method, is a method that can reduce the volume of waste. Yeah, it can actually reduce up to 50 to 70% of the weight of the waste, of the total waste weight. Yeah. So it is a good option because it can reduce up to 70% of the waste generated. Yeah, and why it is a good option? Because it is a natural process, and normally for organic waste, biological process is actually the most suitable. Yeah, because it is naturally, we don't have to add chemicals, we don't have to add more additive, yeah. So it is suitable, especially when we are talking about organic waste. It contains about 50%, almost 60 to 70% of water. Yeah, when we are talking about food waste, it contains a lot of water. So if we are thinking of burning the waste, we have to think about how much water that needs to be burned. Yeah. So if we are talking about incineration, yeah, you know incineration. Incineration is a technology where we are burning the waste. Yes, some developed countries such as Singapore, even Singapore, they have incinerators to burn the waste, and actually burning the waste can reduce as high as 90% of waste. But if we are looking at the product usage, yeah, composting can give benefits to the country or to the nation because it can provide easy fertilizer, easy organic fertilizer to be used in agriculture. Yeah. So it has many advantages. Okay, if we are talking about the chemical reaction, yeah, so biological and chemical reaction where actually it is being, the process is being done through the metabolism of the microbial activities. Okay, so when we look at this reaction, organic waste plus oxygen, yeah, so there would be carbon dioxide being produced, there would be water produced, nitrogen oxides, sulfur oxides, organic residues. So this is what we want as the product, and there would also be some heat being produced from this process. Okay. Okay, composting fundamental process. Yes, so I've already mentioned to you earlier. Okay, so when we are talking about food, yeah, or food waste, so of course in our food waste there would contain proteins, amino acids, lipids, carbohydrates. Yeah, if we eat more rice, more bread, there would be more carbohydrates present in our food waste. There would be cellulose, lignin, ash. Yeah. So when these types of characteristics of the food waste, and so the product will would also consist of valuable nutrients to be used as in the agriculture. Yeah. Okay, so just to inform you that composting can transform biodegradable organic into stable materials, which is the compost. It destroys pathogens. I mentioned to you, bad microorganisms will be destroyed, insect eggs will be destroyed, yeah, and other microorganisms will also be destroyed because of the heat present. Okay, and it will retain nutrients. Yeah, what is important for plants is NPK, yeah, nitrogen, phosphorus, and kalium, yeah. So NPK is important for plants' growth, and the compost process can provide that, yeah. Okay, and it produces product that can be used to support plant growth. All right, so the main steps in composting process because composting process, there have been some industrial scale that being developed, yeah. So there need to be a preliminary process, meaning that before the food waste or before the waste being placed in the pile, in the compost pile, it should be there should be another pre-process, yeah, which is called preliminary process, and then the main process and the product packaging. Okay, so what is the from this flow chart, we can see that okay, this is the main process, yeah, this part which are using windrow method, static pile, in vessel, yeah. So this is the main part, but the pre-processing will be meaning that it will pass through various process, yeah. Okay, when it is entering the composting facilities, okay, there should be a receiving areas, and then if the food waste contains other materials such as plastics, some aluminium cans, some other things, yeah, plastic bottles or others, it should be removed, yeah, because these materials cannot be composted and is actually can make the composting process problematic, yeah. So it needs to be removed, okay, and then it should be meaning that it needs shredding. It needs to be cut into a smaller pieces, yeah, especially I mean fruits, which is very hard fruits, such as what we call that the skin of the watermelons, for example, yeah. So those waste need to be cut into a smaller pieces. Otherwise, food waste such as rice, yeah, rice or vegetables may not need to be cut into smaller pieces because it's already soft and it's naturally becomes very small sizes, yeah. Okay, so it needs to be shredded to cut into small pieces, and then if there is actually iron, yeah, or tin cans present, it needs to be removed, yeah. And then the pre-treatment, that we need to add additives, yeah. If the waste is too wet, for example, if it's too wet, then we need to add bulky agent, something like sabut kelapa, yeah, something that can absorb extra moisture from the waste, yeah. So we need to add those materials, and then only we can go through the process in the windrow, the electrostatic pile, and others. And then after the process, we need to wait until it is matured, meaning that because after the process itself, the microorganisms still very active, yes, still quite active. So we need to place it in for some time in order for the compost pile to be matured. So we have to wait for like a few weeks for it to be matured, and then after that, then we are putting it into packaging and so on, and sending to the consumers. Yeah. Okay. Okay, now when we are talking about material balance of a composting process, okay, let's say we are putting around 2.22 tons of waste, for example, yeah, which is 100%. Okay, so during the process, there are some materials that need to be taken out, yeah. For example, plastic bottles and others. So probably it's about 50 kilogram of those materials, and then it is around 22% of 2.22% of waste being taken out, yeah, from the process itself, yeah, from the material balance. And then we can say about 2.6%, there would be water that will be evaporated. And then during the composting process itself, and then when screening, some carbon dioxide will be released, yeah. And then steam and carbon dioxide will be released. And then oversized material will be taken off, which is not appropriate, not suitable. So about 5% of it will be taken off. And finally, we will get around 66% of compost product from the total 100% of waste input. Yeah. So from this material balance, we can say that in order to obtain a compost product, there are some of the waste that being treated will be removed as oversized materials, as reject materials, as carbon dioxide and steam, and also water being evaporated. So that's why we are obtaining about 66% of compost product. Okay, any questions until now? Okay, do you need to have a break or can we continue?
Yes, doctor, you can continue.
Okay, so we hope that we can finish earlier. Okay, so fundamentals process requirement. Of course, we are talking about microorganisms, which is aerobic microorganisms. And then, early stage, I've already mentioned, mesophilic bacteria, which are active at around 30 to 40 degrees Celsius. And then when the temperature getting higher, there will be thermophilic bacteria will be active during that time. Yes, so the temperature of the pile will be hot, will be very warm. Yeah, and then during the thermophilic bacteria, thermophilic phases, the fungi will be active. Yeah, around 4 to 5 days. And as the temperature drops, mesophilic bacteria will be active again, and fungi will reappear. So at later stage, there would be protozoa, nematodes, millipedes, worms, and other microbes will be doing their activities, will eating up the food waste or the waste that we are treating. Yeah. Okay, so you can see that the for at least for 30 days, yeah, for a month, we can see that the initial temperature will increase, yeah, until, so this is what we call mesophilic phase, whereby the mesophilic bacteria will be active in eating up the food, yeah, and then until it goes high up, the temperature will increase. Okay, so if the temperature will increase too much, yeah, it creates problem, yeah, because we have to ensure that the temperature is at optimum. Maximum is 70 degrees. So when the temperature gets higher and higher, and we have to make sure that aeration, yeah, we have to add oxygen, yeah, whereby we are turning the waste using mechanical turner or using a scraper, yeah, in order to introduce oxygen so that the temperature can be optimized. Yeah, because if the temperature is too high, it kills off even the good microorganisms or the good bacteria. Yeah, so meaning that we have to control the temperatures so that it won't go too high, and it just maintain between 55 to 60 degrees Celsius for a number of days, for at least 14 days. Yeah, and then the temperature will naturally reduce again until it become matured. Okay. Right. Okay, so what are the control? What do we need to control for during the composting process? Okay, as I mentioned, the first thing is that moisture content. Yeah, especially our food waste, it contains high water content, probably until 50 to 60 percent. Yeah, so we need to reduce the amount of moisture content. Yeah. Okay, meaning that if it's too wet, if it goes as high as 80% or more, we have to add something else. Yeah, probably fruit bunch, yeah, fruit bunch or anything that can absorb extra water. Yeah, and then we need to ensure that oxygen is enough. CN ratio, which is the carbon to nitrogen ratio, 25 carbon to 1 nitrogen. Yeah, so that the food for the microorganisms will be there. Yeah, and it will boost the process itself. Yeah, and avoid low carbon to nitrogen ratio because it will release ammonia. Yeah, if the carbon to nitrogen ratio is too low, ammonia will be released, and then the biological process will slow down. Okay, and then the particle size, that's why I mentioned to you just now, it needs to be shredded. It needs to be cut into smaller pieces for the hard type, the food waste that are very hard need to be shredded. Yeah, 25 to 75 millimeters in size. And then the optimum temperature that need to be maintained around 50 to 60 degrees Celsius. Okay. And then mixing, yeah, make sure that the compost pile is well mixed, because carbon, nitrogen the microbes will need both. Yeah, carbon to nitrogen will need water, will need oxygen, so it needs to be mixed very well. Yeah, and if we are adding sludge, yeah, especially if we are adding, because sludge contains a lot more of microorganisms. Yeah, so when we add sludge, yeah, we can add sludge to the compost process. I think you have learned about sludge already, right? Sludge from the wastewater treatment plant. Yeah, so we are taking sludge from the wastewater treatment plant, we add together to the food waste. Yeah, so there will be more microorganisms that will present and make the process more faster. Yeah, so that the process will complete within a shorter period of time. Okay. Okay, then so mixing is required. Turning, yeah, turning, as I mentioned, we can use mechanical turning, yeah, or even manual turning by using a spade, scraper, yeah. So that air supply will be increased and will be reduced moisture, and it will become more uniform conditions. Okay, pathogens, I mentioned bad microorganisms need to be killed off. So in order to kill off, the temperature will need to rise as high as 65 degrees Celsius to 70 degrees Celsius. Okay, what else? Stage of decomposition. Okay. Land area requirement, this is like a rule of thumb. For example, 50 tons of waste per day will require approximately 1 hectare of land. Yeah, so actually composting process require quite a large land area. Yeah, because the process itself take quite a long time, a long duration. So probably some 1 month or 1 month period or almost 2 months. So it requires quite a large area here. And if you are choosing the technology, for example, are you going to use windrow composting, aerated static pile, or a reactor, yeah, a closed system? So it depends on the capital and operational costs that available in the community. Is there enough finance for the treatment process? So it needs to be calculated, yeah. Okay, and also we need to consider the area, the available area, environmental considerations, and expertise for technical issues, yeah. Okay, so this already mentioned, this summary for the design of the composting facility. Okay, so the properties of the compost product. Okay, the color would be brown to a very dark brown, yeah. It should have low carbon to nitrogen ratio. Although during maturation phase, it is sometimes changing, it continuously changing in nature because of the microbes still present, and some of the microbes will still continue to do their activities. And it should have high capacity for cation exchange and water absorption. Okay, so from the food waste that we can see here, it goes into something, a product like soil, yeah, yeah. And this is a better compost product. It is more dry, yeah, it's drier than before. I think this just now is just completed, meaning that it needs a little bit more time in order for the moisture content to be reduced, yeah. And this is the product itself, yeah. And here at the bottom right hand is actually a large scale. It's industrial scale composting, yeah. And normally in Malaysia, palm oil industry here will use windrow composting, like Sime Darby. Actually, they are also doing composting process to treat palm oil bunch, yeah, fruit bunch, yeah, using composting process. Yeah, we have already visited the facility few years back before pandemic, that we can visit to various treatment facilities. This one that we have visited in Teluk Intan, Perak, yeah, it's a very large scale composting process, yeah. Okay, faedah, the product, yeah, it can become organic fertilizer, yes, to improve soil, in supplying humus and nutrients to the soil, and it provides a rich growing medium or a porous absorbent materials that holds moisture and soluble materials. So it is very good for plants, yeah, as fertilizer. Although now organic fertilizer is competing with chemical fertilizer because it is cheaper, but more people, yeah, more farmers will prefer organic fertilizer, as it actually will produce a better products, less problems with meaning that the chemicals, yeah, without chemicals for the products that being produced, yeah. All right, the advantage of composting: increase nutrients to soil and capacity in absorbing water, reduce organic waste disposal to landfills, and reduce adverse impacts of waste to the environment. So overall, this is the advantages of having the composting process. Okay, so already mentioned. Techniques already mentioned. Okay, so this is a home composting scale, meaning that you can have the composting process at the back of your house. Yeah, one is probably for the garden waste, and probably the combination of garden waste and food waste, selected food waste. Yeah, because in order to ensure that no rats or other animals that get into your bin, so it's better to have a selected items, yeah, a selected food waste for the composting process. And you can make it layered, yeah. Probably at the bottom would be like branches, some tree branches, and then the next layer would be leaves, and then the next layer would be some food, and then put another layer so that oxygen can easily, aeration can be provided in the pile itself. Yeah, so this pile is actually being placed in what you call that wood area. Yeah, so it can be placed in a container, or it can be just a pile itself. Yeah, a large, quite high. The pile itself. Yeah, without having wood being located surrounding it. Okay, this also home scale composting, and you can also make it like having mesh wire, yeah, mesh wire, and having, this is a simple process, yeah. Okay, and you can also put it in a pot, or you can make it into a pile that we call it windrow composting. Okay, so this is the composting facility at UKM. Yeah, this is a site layout. These are actually one of the place. We call it first barn, yeah, composting barn. And then these are initial pile, waste pile that we have used. Okay. So this is initial during early stage of composting facility at UKM. So we are putting doing our own effective microbes or our own enzymes. Yeah, yeah. There's actually a recipe, a simple recipe to create enzymes to provide effective. We call that effective microbes. This enzyme, we call it as effective microbes, in order to enhance the microbial activities. Yeah, so we can add that in order to improve the process itself. All right, okay. And here we also have made a trial at some of the cafeteria at UKM previously. I think this was in back in 2010. Yeah. We have tried few cafeterias, providing them with a compost bins, so that the food waste can be thrown here together with some garden waste, yeah, landscape waste. And this is another type, which is a rotary drum. Yeah, that we need. This one is using manual turning, but in fact there could also be mechanical turning. Yeah. Okay, so another yard waste composting. Okay, so this is a large scale windrow, and you can see that this is a mechanical windrow composting, mechanical turner. Yeah, so this equipment will turn the waste so that aeration can get in. Yeah, oxygen can get in, and it will provide a good aeration for the compost pile. Okay, this is another mechanical turner. Yeah, another types of mechanical turner. All right. And okay, this is another picture of aerated static pile. As you can see here, there would be blower. Yeah, there would be a blower, and then oxygen will be pumped into pipes at the bottom of the piles. Yeah, so that and then there would be perforated holes. A perforated holes at the pipe so that oxygen can be introduced into the pile. Yeah. And this is another picture of a blower. Okay. Okay, this is a very large scale composting facility using rotary drum. Yeah. What else? Okay, another in-vessel composting, yeah, that we call bioreactor. So for in-vessel composting or bioreactor, it is even a controls. It can be oxygen, water content. Yeah. It can be controlled mechanically so that less human intervention is required, and it can it can detect when there will be enough oxygen or enough water being present in the bioreactor. Yeah. All right. So issues. Okay. In order to build or to construct a composting treatment or composting facility, there are various issues that we need to identify, yeah, before we start or before we are proposing for a composting facility. Firstly, make sure there is a market that we can sell the products, the compost product, yeah, because if you cannot sell the product, then you will be left with lots and loads and loads of organic fertilizer that cannot be sold. Yeah, so make sure there will be market for you to sell the product. Okay, and sometimes it is a very small diversion of waste from landfill, meaning that if it's not being properly or if it's not a large-scale composting facility, then very little waste can be diverted from landfill, meaning that only small amount of waste that is actually being diverted from the landfill. So you might be, if you are working at the local municipality, yeah, local authority, the composting, very little amount of waste being diverted from the landfill because it is quite a small facility, and then from it we can say that very little waste actually being diverted. Yeah, so sometimes it is frustrated to the local authorities. Yeah, and then be careful of the environmental impacts such as the pathogen risk. Yeah, meaning that if the temperature is not high enough to kill off the pathogens, then there would be environmental impact or even health impact. Yeah, and also if the facility is not being controlled very well, then bad odor will actually, you can smell it quite from a far distance. Yeah, so those are the issues that we need to consider. Yeah, all right. Okay, so related issues, odor generation, presence of pathogens, sometimes contamination of heavy metals could be there as well, yeah, and also the presence of non-decomposable waste, yeah, meaning that probably some straws, yeah, or probably some plastic bags will get into the compost as well, yeah. So those are the issues that is currently that we can see in the composting facility. Okay, so sometimes sometimes the bad odor came, yeah, during the composting process. So we encounter bad odor problems at the composting facility. So why is that so? How does the bad odor being generated from the process? Okay, so some of the problems are why is it so? It is because low in carbon to nitrogen ratio. Yeah, carbon to nitrogen ratio is low. Yeah, it's not, the optimum will be 25 to 1, 25 carbon to 1 nitrogen, but when it is low, it can create bad odors. Yeah, and then temperature control. So probably the temperature is not high enough. It's just like 30 degrees Celsius. Some problems with microorganisms that it is not really active. So when the temperature is low, it creates bad smell as well. Then moisture. When the moisture is too high, probably more than 70% of moisture present in the pile, then the facility will create bad problem. Yeah, and also make sure that the waste being mixed properly. Yeah, if it's poor mixing, then it can create bad odor. Okay, so how to manage odor? Okay, one of the things that we can make sure is that, of course, make sure that the CN ratio is at optimum ratio. Temperature should be high enough, yeah. Water content, mixing well, and then you can also add additional protection, such as application of activated carbon contactor. You can use biological filters, and you can also add enzymes which can decompose odorous organic compound. Okay, those are the best option that you can do in order to control bad odors at the composting facilities. Okay, so that's it about composting, aerobic composting. Okay, before I end my lecture today, remember just now I'm talking about aerobic composting. So now we are going into another type of composting, which is without oxygen, anaerobic. Yeah. So the next, it is also a treatment process for organic waste, but it is another type, another process. We call it as anaerobic digestion facility. Without the microorganisms, which are also present in the aerobic composting process, but this one it will be activated. Yeah, the microorganisms will be active and will be activated when there is no oxygen present at the in the food, yeah, in the waste, yeah. So this is a picture of anaerobic digestion facility in Germany. Okay, so this facility, anaerobic digestion facility, is thought to be one of a good option because it provides all renewable energy. Yeah, by having this process, yeah, by doing this process, we are gaining energy from the waste. So many researchers, many industrial parts, yeah, industry companies, yeah, will think that, oh, this is a very good option in order to generate renewable energy, yeah, because people are talking about renewable energy worldwide. So this is quite a good option, yeah. Okay, so when we are talking about renewable energy, what types of waste that can be used for anaerobic digestion? So we are thinking about at the farm, yeah. So animal dungs, yeah, such as cow dungs, yeah, can be used as the feedstock. We can also see from the food processing, yeah, the manufacturing of food, yeah, during the food processing, there will be food waste, and also from our home, from household, and also from the commercial areas, restaurants. So it can be taken, these waste can be taken and blended, yeah, it needs to be mixed and blend, and then it will go to the anaerobic digestion facilities, being pasteurized, yeah. Yeah, because anaerobic digestion, it can produce renewable energy, such as it can produce electricity, it can produce heat and gas, and there will be also byproduct. Yeah, byproduct means that the sludge from the anaerobic digestion facility can be dried up and it become compost. It can be dried up and become organic fertilizer as well. Yeah, so using by having anaerobic digestion facility, we can also obtain another product instead. The main product would be renewable energy. Yeah, the byproduct would be organic fertilizer from the sludge that being dried up. Okay, I hope that you understand. We are now. This is also a biological and biochemical process, but with different conditions. Yeah, I hope you are not confusing with aerobic composting and anaerobic digestion. Okay. Any questions? Because we are going to the next topic. Any questions from you, from the students? Anything that you are not? Am I going too fast?
Question.
No question? Okay, yeah, you can understand. I hope. Okay, because I cannot see your face. I used to see my student's face, so now I couldn't see. So I'm imagining your face now. Okay, I hope I'm not imagining a blur face. I hope you are, I hope that I'm not seeing a sleeping face. Okay. Because we lecturers cannot see the students, so we don't know what you are doing, what you are thinking. Okay, at UKM, we also have, we called it as UKM Biogas Pilot Plant that we have tried. Initially, we tried with leachate, meaning that dirty water coming from organic waste, yeah? So we are converting leachate into renewable energy. Renewable energy means we are concentrating on methane gas. Yeah, you know methane gas, CH4. Yeah, because the process, the anaerobic digestion process will produce methane gas. Yeah. Okay, so we have tried that. It's under research at UKM. We have anaerobic digestion pilot plant nearby the Permata Pinta, UKM. Yeah. Okay, I think I've already mentioned to you earlier this one. No need to go again. Okay. Okay. This is actually the theory about anaerobic digestion. So when we are talking about anaerobic digestion, we know that organic materials will decay or will biodegrade under anaerobic conditions without oxygen, and it will produce gases, yeah, such as methane gas. Yeah, so this is the main gas that being produced: CH4, methane gas, carbon dioxide, CO2, small amount of hydrogen sulfide, yeah, ammonia, and others are produced. Okay, so anaerobic digestion process has a different products. Yeah, even though there would be sludge. Yeah, byproduct would be sludge that can be converted into organic fertilizer as well. Yeah. Okay, but the gases, yeah, mostly gases that being produced will be CH4, methane gas. Yeah, of course there would be carbon dioxide. So carbon dioxide is not actually good because it can add up to the global warming, but it is very minimal. Yeah. Okay. Methane gas has long been recognized as excellent fuel. Okay, recently it has been an option for alternative energy to replace depleting fossil fuels. So why people are looking into alternative energy? Because fossil fuels is getting less and less and less. So people have to think about alternative options to get energy. Yeah. Okay, so generally the anaerobic process, it is a biological conversions occurs in 3 steps. Okay, 3 phases. Yeah, we call that 3 phases. Okay, this is the reaction. Yeah, meaning that this is actually the waste, the organic waste. So during the conversion, mostly it will produce CH4 and also it will produce carbon dioxide. And actually carbon dioxide will be trapped as well together with CH4 if we are taking the methane gas as energy to be recovered. Yeah. Okay. So the pathway leading to the production of methane and carbon dioxide from anaerobic digestion. Okay, so we are talking about the food, our food, yeah. So of course, our food contains carbohydrates, contain fats, sugars, contain fats, proteins, yeah. So it will be converted during the first process, during the we call it hydrolysis process. We convert carbohydrates into sugars, fats into fatty acids, proteins into amino acids. Okay, so this is the first step, the first phase, the first process. Then after it becomes, it will continue to produce during the acidogenesis process. These sugars, fatty acids, amino acids will change into carbonic acids and alcohols, hydrogen, carbon dioxide, and ammonia. Okay, then it passes through another stage which is called acetogenesis, which will convert this into hydrogen, acetic acid, and carbon dioxide. And finally, the last phase, methanogenesis process, then only we can get methane and carbon dioxide. Okay, right. Okay, so this is very long, but it's explained what I mentioned earlier, yeah. Okay, mesophilics. Okay, what is it here? Anaerobic digesters can be designed and engineered to operate using a number of different process configurations. So meaning it can be a batch process. Batch meaning one batch going into the process, complete, then get another batch going into the process, then complete. Or it can also be a continuous process. One batch going through the process, it will be continuously. I mean, the feedstock will go into the facility and it is continuously. So probably for 24 hours process, yeah. Okay. Okay, the temperature, it will be from mesophilic temperature to thermophilic temperature, meaning that it can go as high as 50 to 70 degrees Celsius for thermophilics. For mesophilics, from 30 to 50 degrees Celsius. Yeah. Solid contents, it can be high solids, meaning that it can be very thick with high solids, or it can be very small amounts of solids. So it is operation in a different scenario. Yeah. And it can be complex. Either it can be single stage, meaning that you are doing only single stage, or you can make it into multi-stage. Okay. Okay, so here, I think I've already mentioned fertilizer and soil conditioner. So actually from the byproducts, we can also produce fertilizer, yeah? Meaning that after the process, the anaerobic digestion process completed, there would be sludge being produced, yeah? So this sludge may need to be dried up, yeah? By using composting process, drying up, meaning adding some bulky agents to reduce the amount of water content. Then using the composting process, the aerobic composting process, then we can produce organic fertilizer as well. Yeah, so it can be multi-stage, meaning that the first stage is anaerobic digestion, and then the second stage would be aerobic composting. So we can get more products from the biological treatment facility. Do you understand? Is it okay for you? You still can get it? Yeah, I hope you can understand. All right, this is a commercial anaerobic digester. So there's another mechanical biological treatment plant in Germany. Okay. So a little bit more. Okay. World. Okay. I think Dr. Irfana has already mentioned that she have taught you about BSFL, isn't it? Black soldier fly. Do you remember?
Yes, Doctor.
Okay.
Yes, Doctor.
Okay, I just want to highlight to you. Maybe I will share. What I want to share? Or here, I think. Okay. Oh, here. Okay, can you see? Can you see my slide? No.
I can see. Doctor.
You can see?
Yes.
Oh, okay. So this is our project.
Tapi Doktor, PowerPoint tak keluar lagi.
Tak keluar? Oh, okay. Ya. Yang ni nampak kan? Tak boleh.
Doctor,
Yeah.
I think you share the wrong.
Oh, yeah.
First time you only show your window panel, not the PowerPoint slide, so we just can't able to see it.
Okay.
Maybe you try to
just
reshare
now.
the slide.
Mana ya? Okay. Mana pula begini? Okay, I will share. Okay, this one. Okay, can you see this one?
Boleh, Doktor.
Boleh ya?
Yes.
Tapi macam kecil Is it small?
Tak. Okay je, Doktor.
Okay, so this is the research that we are doing at UKM regarding BSFL, Black Soldier Fly Larva. Okay, just want to show you. Okay, for the Black Soldier Fly Larva, what we did at UKM, we need to provide a place where we can breed the fly. I think if you know, I think you, Dr. Irfana have already shown you what are the flies. So BSFL can be actually done in quite a small area as well. Okay, but make sure that you can breed the fly and get the eggs, so that the egg will hatch up and then will produce larva. Okay. All right, so we need to have eggs. Okay, so if you look at this picture, you can see there are some eggs in the holes, Dalam lubang ni ada eggs, ada BSFL eggs. So we need to get the eggs, Get the eggs for the process, for the treatment process of food waste. Okay, here also you can find the eggs will hatch. Okay, will hatch and then this still. Okay, this is still the fly. Okay, so here we can see the eggs being hatched at the bottom left, and then we are feeding the eggs with our food waste. Oh, kan. Sorry. Ada lagi tak? Okay, so we are feeding the food waste to the larva, and then the larva will eat up the waste, and the larva will be very fat, very large, and then actually the product would be the larva itself. Yeah, the larva will be actually, it can be sold as, I mean, the product will be animal feeds. Yeah, animal feed to the either to the fish or even for the chicken. Yeah, but sometimes people don't sell it as larva itself. It will be dried up and make into powder. Yeah, or other suitable products that can be given to the animal as animal feed. Okay, so these actually now people are looking into this treatment option because it is simple, less technology, and then there are various products that can be produced using BSFL. Yeah, so one of it is as animal feed. Others, I think, there will be frass. Frass is actually when the larva eat up the food, then it will give, I mean, the byproduct will be their tahi or their dung. Yeah, this tahi or dung will can be used as organic fertilizer as well. Okay, so there's two products already. And then people are talking about chitin. Chitin is actually a layer that is surrounding the larva. Yeah, a natural layer surrounding the larva that actually being released when the larva is getting big and bigger. So chitin will be released, and it is suitable for pharmaceutical products. Yeah, pharmaceutical products. So there are various products that can be obtained from the BSFL. Okay, so that this is actually a research now currently being done at UKM, and I think few students, even I think someone has mentioned that she is also, I think Rachel, yeah, Rachel, you are doing BSFL, right, under
Yes,
Dr. Ifana. So now probably you are reading information, doing literature review about BSFL. So it has a very good potential of being commercialized. The products being commercialized. Yeah.
Yeah.
Right. So this also a study that we have done at UKM. Is that okay? If you can see at the bottom right-hand side, so that's the chitin that we can obtain from the larva. Yeah. So, all right. Okay. This one is BSFL. Another one. Macam mana ya tadi? Macam mana nak unshare? Macam mana boleh hilang? Okay. Another one is what? Vermicompost. Yeah, vermicompost. Kat mana pula? I'm having problem of unsharing. Kat mana pula unsharing ni? Banyak sangat file dia sini.
Doctor, you just look at the top right corner and then there got something like a rectangle shape icon. You just click on it and just unshare your content. And then if you want to share it back, just click one more time. And you try it out, see whether it works or not.
Okay. All right. Okay. So the last one is the vermicomposting, but I cannot find the file. Okay, where's that? The file. Okay, here. All right. Vermicompost. Can you see the file? No.
So I think you share the file after you open it, not you just open it in your window panel. After you open it, you try to share it again, and you can see, I think.
Okay. So I already. So now you cannot see, yeah, the file.
Yes.
Okay. Hopefully, this one you can see, right? Can you see? No.
Yes, can see.
Oh, you can see. Okay. So another option is vermicomposting. Yeah. So what is vermicomposting? It is another technology using worms and emerging technology for recycling of crop residues and other organic solid waste by utilizing earthworms to convert them into vermicompost. I mean, the product is called vermicompost. Okay, so vermis means worm and cultural means growth. Okay, vermicompost is a method of making compost with the use of earthworms, which generally live in soil. Yeah, so normally the earthworm is actually a strong earthworm, and in Malaysia we actually import. It is not a local earthworm. Normally that we have, the one that we are doing now is imported from African countries. Yeah, it's an African earthworm. Yeah, the end product of vermicompost is. The end product of vermicomposting is called vermicompost. Yeah, so it contains nitrogen, phosphorus oxide, yeah, potassium oxide, yeah, and the earthworm consume large quantities of organic matters and excrete soil as cast. Yeah, vermiculture, a scientific method of breeding and raising earthworms in a controlled condition. Okay. So this is the worm. The species of the earthworm is called Yersinia fotida. Yeah, and also another vermi species is Irudrillus everginae. Okay, so this is the species name of the worm. So earthworm is physically an aerator, crusher, mixer. Okay, just now we learned about so many technologies, but the earthworm itself, yeah, themselves, they are the technology that will do the process of treating the organic waste, yeah, of the food waste, yeah. So it is a mixer, chemically degrader, and biologically simulator in the decomposer system. Okay. Then the nutrients, as mentioned, it contains high organic carbon, total nitrogen, phosphorus, potassium, calcium, magnesium. Okay, so much nutrients in the worms, yeah. And then it has the favorable conditions for earthworms in the composting materials. So the pH should be in optimum level, 6.5 to 7.5. Moisture content is quite high, 60 to 70%. It needs aeration of 50%, and also the temperature is not too high, 18 to 35 degrees Celsius. Yeah. And then this is a picture of vermicomposting under thatched roof to protect worms against rain and sun. Okay, we can also use polythene to actually provide a space for the worm to eat up the food waste. Yeah, and it's under the roof. Yeah, and we can put some leaves, yeah, coconut leaves on top of it to provide shading for the worms to have a good condition for them. Yeah. And then we have to make sure that the food that we are providing the worm should be finely chopped, because it is much easier for the worms to eat up the waste, the food waste, and will do their work. Yeah. Okay, what else? The procedure. The procedure mostly prepared in either pit or heap method in a shady area in the farm, like the picture that we have shown earlier. Dimensions could be 10 times 4 times 2 feet. First layer bedding materials with 1 inch thick with soft leaves. And then we put a second layer, about 9 inch thick organic residues layer, finely chopped materials. So the materials that, meaning that the food waste that we are providing for the worms should be chopped. Then the third layer, we will add some dung and water, equal mixture of 2 inches layer, and then continue the layers up to ground level. And we have to make sure that regular watering should be done. Okay, not a very complicated system, but it worked well to treat the food waste. Yeah. Okay. And then at the day of 24th, 4,000 worms are introduced into the pit, meaning that we will add on the day of on the 24th day, we add around 4,000 worms. Okay, the temperature at the beginning may reach up at 66 degrees Celsius. Hence, introduction of earthworms should be done after 2 to 3 weeks. Okay, after the heap cools down, holes should be dug and 50 to 100 earthworms should be dropped in each hole. Okay. After a few days, earthworm will begin consuming the organic matter and leave rich castings behind. All right. So harvesting from the pit. During harvesting, stop watering before 1 week of harvest. All the worms spread across the pit come in closer and form balls in 2 to 3 locations in the side of the pit. And then heap the compost by removing the balls. So from there we will get compost itself. Then the materials is sieved in 2 millimeter sieve. The material that passed through the sieve is called vermicompost, and it should be stored in the vermicompost in polythene bags. Okay, so this is the sieving process of the compost product using vermicompost process. And then it should be packed in bags. And okay, turnover of the compost is 75%, so it's quite high. The total material accommodated in the pit is around 1,000 kilogram. And outturn, meaning that what we can get is 750 kilograms. So what is the conversion rates? 1,000 earthworms may convert 5 kilogram of waste materials per day, and then 1,000 worms with about 1 kilogram. Okay, what else you should know? Okay, application rate. It can be applied in any crop at any stage, but it would be more beneficial if mixed in soil after broadcasting, meaning that the rate of application is for the field crops 5 to 6 tons per hectare. For vegetables, 10 to 12 tons per hectare. Flower plants, so it has a different rate for different types of crops that we are doing, or even for fruit trees. Okay. Advantage of vermicompost. Vermicompost is a rich source of nutrients, vitamins, enzymes, antibiotics. Okay, so much advantage of having a vermicompost, and growth hormones. Okay, so it gives disease resistance to plants. Okay. Then nutrients contents of vermicompost is higher than the traditional compost. It is valuable for soil amendments. It is a vermicompost harbors certain microbial populations that help nitrogen fixation and phosphorus solubilization. Okay, so it is good to help the nitrogen and phosphorus. Okay, its application enhance nodulation in legumes and symbiotic mycorrhizal association with the roots. Okay, so advantage for the roots as well. Okay, so I think there's a lot more advantages. So that's it, I think. Okay, so that's all. All right. Where is my... Okay, so it's already 1 o'clock. Can you see me now? I'm not sharing anymore, right?
Yeah, you're not sharing anymore. We only see your video cam.
All right, so I just want to take your attendance. Yeah, just a moment. Oh, my light is already off. I'm talking too much. Okay, so I've already taken your attendance. Anything that you would like to ask me before I end my lecture today? Oh, yes, I have one assignment for you. Before I forget. Where is my assignment? Maybe it's here. Assignment 6. Hilang lagi. Tak nampak So okay. Assignment. I don't know, he's here. Assignment 6. Okay, can you see my writing?
Yes.
Okay, assignment 6 about the technology for biochemical treatment. Okay, I'm giving you a scenario. Okay, from a waste composition studies conducted, we found out that the households generally generated around almost 50% of food waste, yeah, from the total of daily waste generation. So I mentioned to you, normally, yeah, from the study that we have done, we found out that quite a high number of food waste being generated in household, yeah, from our home, yeah. Okay, so we can say from our study just now, from the lecture just now, theoretically, biochemical and biological process is suitable to treat organic waste, including food waste. So because it's a natural process, it's a biological process, so it's suitable to treat food waste. Okay, what you need to do is to suggest which biochemical and biological process would you select for your home. Okay, it can be either for your house, for your home, or you can also make it bigger as a community, meaning that in your kampong or maybe in your taman area, yeah, in your housing area, your taman. So it can be individually at home, or it can be at your taman, yeah, at your community area. Okay, suggest what are the process that you would choose. Okay, the technology can be chosen either composting or anaerobic digestion, yeah, BSFL or vermicompost. You can choose any one of these, and you should provide justification on your selection why you choose the technology, which is you need to refer to the waste that being produced from your home, yeah, the waste input, the amount of waste, the loading capacity, the land area, area in your house, in your housing area. Maybe then maybe technical requirement. Do you know how to do the process? And then about the product usage. Is the product beneficial to the community, to your home? And also, is there anyone who will buy the product? Yeah, if it's a larger scale. Okay, I will give you 1 week, yeah, until Friday next week for this assignment. Anything that you would like to ask regarding this assignment? No? Okay, I will upload the question in a short while. Okay. Okay.
Lecture, we need to write in essay form, right? So is there any word requirement, something like that? Maybe like more than 1,000 word, 2,000 word, something like that? No.
Actually, no. It's up to you. I mean, but not more than 10 pages. Yeah. You may add pictures. If you can search from the internet, you can add pictures, but not more than that. Not more than 10 pages. At least probably 5 pages will be enough. Yeah. Okay, no specific number of pages, but around 5 pages, something like that, with pictures. Okay. Anything else? I think I better stop sharing, stop recording. Okay, so any questions from you anymore? Okay, so I think that's all for today. Okay, for next week, I will be doing recording for the class. So I will upload for the recording because I will not be at UKM next week. So I'm doing a recording of my lecture. Then you will you watch my lecture, and if there is any questions, you can always ask me anytime. You can WhatsApp to me. Yeah. All right. Okay, so thank you very much for listening to my lecture, and hope to see you again anytime after this. Yeah. Okay. All right. Okay. Thank you. Thank you very much. That's all for this week. Okay.
Thank you, Doktor.
Thank you, Prof.
Okay, sama-sama.
Okay, Doktor.